Hello. All right. In this video, we are going to talk about gravitational forces. And we're going to be able to construct and present arguments using evidence to support the claim that gravitational interactions are attractive and depend on the masses of interacting objects. So gravitational fields and forces. The force of gravity, which exerts a gravitational field and acts at a distance like magnitude or electric fields. Okay. Gravity is a force that pulls every object toward every other object. That means we all have our own gravity. However, the force of attraction is very weak unless one of the objects is very large. Because Earth is very large, you can feel it pulling on you. This pull is called your weight. You can't feel the pull between yourself and smaller things, such as other people, because the force is too weak. Gravity is always a pull, never a push. Okay, mass and gravity. Instead of saying Earth is large, we should say it has a lot of mass. Mass is what makes up all things in the universe. The more mass an object has, the harder it is to move. Gravity is the attraction between any two masses. The force of gravity is stronger when the masses are greater or the objects are closer. If you move farther away or decrease the mass, the force gets weaker. Mass versus weight. Scientists understand enough about gravity to predict how it will affect different objects. There are even ways to calculate the force of gravity between two objects. Scientists can use these formulas to calculate the mass of newly discovered planets, determine how much fuel a rocket needs to lift off from Earth, or calculate how fast a rover will be going when it lands on Mars. All of these things depend on the force of gravity. Many people speak of weight and mass as if they're the same thing, but they're not. Mass is the amount of matter something has. Weight measures the gravitational pull on an object's mass. So I have a specific amount of mass on Earth. I have a different weight than I would have on the moon because the moon mass than Earth, so it has a lower gravitational pull, so I would have a lower weight on the moon than I would on Earth. Alright, so gravitational force is an attractive force. It pulls things together, it never pushes. Gravitational fields are produced by all objects that have mass. Gravitational force is very hard to measure in objects that are small, but is still present. Gravitational fields are usually studied on a larger scale, such as with planets and stars. Gravitational field models are used to explain the influence of a massive body on its surrounding objects. So astronomers could use gravitational field models to help understand the pull of like a star on planets. When we study other planets in the solar system, we can see the gravitational field effects of the sun on each planet. Planets orbit stars because stars are much more massive than planets. However, even though the gravity of the star is much stronger than the gravity of a planet, larger planets can still cause a measurable wobble in the star as a planet's gravity pulls back on the star throughout its orbit. The larger the mass of the planet is, the larger the wobble of the star is. Quick summary. Gravity pulls on all objects. All objects that have mass have a gravitational force. Mass and weight are different in science. Mass is how much matter there is. Weight is mass times gravity. Thanks for watching. Good luck.